Today we'll be discussing about foundation settlement. Imagine a building resting on a bed of sand. If the sand is soft and weak, what happens when the building's weight is applied over it? The sand may compress and shift, causing the building to sink. This is what we call as foundation settlement. Why does foundation settlement occur? There are two main reasons behind this. 1. Weak soil. If the soil beneath a building is soft, poorly compacted, or unable to support the building's weight, it can cause the foundation to settle. This is why it is very important to assess the soil's bearing capacity before construction. As we know, bearing capacity is a soil's ability to withstand the load of the building. 2. Heavy loads. Excessive weight from the buildings, vehicles, or other objects can put undue pressure on the soil. If the soil was not designed to handle such loads, it may compress and cause the foundation to settle. So, based on this explanation, I could define foundation settlement as the downward movement of a foundation due to the inability of the underlying soil to adequately support the building weight. Types of soil settlement. When the load comes over a soil mass, 3 types of soil settlement is out to occur. These settlement occurs at different time periods during the life of the structure, and the sum forms the total settlement of the foundation. Hence, the 3 components of the soil settlement are immediate settlement or elastic settlement, consolidation settlement or primary settlement, SCP settlement or secondary settlement. 1. Immediate settlement, elastic/distortion settlement. Immediate settlement of the soil occurs as soon as a load is applied over the soil, that is, immediately after the construction of the structure due to the distortion of the foundation soil. Here, the load on the soil results in the expulsion of the air from the soil voids, causing elastic compression of the soil beneath. This process rearranges the soil particles and causes immediate settlement. Immediate settlement is calculated using elastic theory, especially for cohesive soil. It is an assumption that we considered while determining the calculations. 2. Consolidation settlement, primary settlement. Consolidation settlement occurs when the water present in the soil gets squeezed out over time. The process reduces the void spaces and rearranges the soil particles. This makes the soil move downwards. It is determined using Tagg's theory of consolidation. 3. Creep settlement, secondary settlement. Creep settlement or secondary settlement, represented as SS, begins after the completion of consolidation settlement. This component of creep settlement occurs throughout the life period of the soil, as long as it is subjected to a constant pressure of the load. Hence, the total settlement is the sum of the immediate settlement, the consolidation settlement, and the creep settlement. Total settlement equals SI plus SC plus SS. Types of foundation settlement. The displacement of a soil leads to foundation settlement. The downward vertical settlement of the foundation can be uniform or differential. Hence, before understanding the causes of foundation settlement and going for repair, we need to understand that there are 2 types of foundation settlement expected. Uniform foundation settlement. Differential foundation settlement. 1. Uniform foundation settlement. Uniform foundation settlement occurs when all the section of a structure undergoes the same rate of settling. It is likely to occur when the entire portion of the foundation lies on the same kind of soil. Also, the loads on the structure are uniform throughout. Now, compared to other types of foundation settlement like differential settlement or curvature settlement, uniform foundation settlement is normal and typically causes less structural damage. However, uniform settlement influences the underground building utilities like sea water supply and jamming of doors as well as windows. 2. Differential foundation settlement. When every portion of the structure on the ground does not undergo settlement at the same rate, differential foundation settlement occurs. Here, different parts of the building structure settle at different settlement values. As shown in the figure, if one part of the structure settles differentially with respect to other parts of the foundation, the structure undergo distortion. The connecting beams, slabs, and interfaces may crack and the floors become unusable. Figure B shows the differential settlement that is tilting. It shows a uniform tilt where the entire structure is subjected to a rotation. Figure C shows a non-uniform tilting, also called as dishing or curvature settlement. Both these types of differential settlement are caused due to non-uniform settlement, that is caused due to non-uniform bearing stress of the soil and non-homogeneous subsoil conditions. As explained in the figure, differential settlement represented as delta S between 2 points is the largest settlement minus the smaller settlement. It is also characterized by angular distortion, which is determined as the ratio of differential settlement between the 2 points and the horizontal distance between them, that is, delta by L. Differential settlement results in cracks in buildings, walls, and distorts the whole structures. Floors might get slope and difficulty opening and closing of doors are also experienced. Major foundation failures are caused due to differential settlement, and hence it is a very critical issue during the design and construction of our building structure. Chances for the occurrence of differential settlement on a site in the future are forecasted by adequate ground investigation and correct interpretation of soil data, which is gathered from the geotechnical test that is conducted. Now to summarize, let's combine the various causes of foundation settlement. Foundation settlement can be caused due to many direct as well as indirect reasons, as we outlined before. Uniform foundation settlement is less detrimental. Differential settlement is a very big concern. Every differential foundation settlement issue hence has an underlying root cause that needs to be studied by a foundation repair contractor or a structural engineer before coming up with a solution. This includes 1. Improper preparation of soil for construction. Before exposing the soil to any structural load, it is compulsory construction practice to properly prepare the soil, compact it, and prepare for the estimated expected load. 2. Improper compaction of soil. To prepare the soil for better bearing capacity, additional soil filling and compaction are performed for a better foundation subgrade. Failing to do this results in foundation settlement. 3. Incorrect estimation of soil bearing capacity. To what extent a particular soil requires preparation is dependent on the current soil bearing capacity. A wrong estimation of soil bearing capacity results in error in the proper preparation of soil, which causes foundation settlement. 4. Low bearing capacity of soil. Lower the bearing capacity of the soil, the higher the chances for foundation settlement, respective of what causes a low value of bearing capacity. 5. Expansive soil. Expansive soils are those soils that expand and shrink considerably as seasons alternate between wet and dry. If a foundation has expansive soil below it and does not expand or shrink uniformly, the movement in the foundation does not become uniform. This will cause stress on the foundation, which could lead to structural damage. 6. Construction activities nearby. Excessive vibration or excavation activities performed near an existing foundation would result in the underlying soil becoming loose support. Finally, it's natural calamities. Natural calamities like earthquake and floods tremendously affect the stress condition of the soil underlying the foundation. Follow for more construction and civil engineering videos.